Everybody, Dr. O here, and in this video I want to talk about the sarcomere and the changes that it undergoes in muscle contraction. So let's get started. So first off, how do we define a sarcomere? Well, one thing we can say about a sarcomere is that it is the functional unit of muscle. And we have to think about what muscle does. Well, muscle generates a contraction. So the sarcomere is going to be that essential unit that creates the muscle contraction. And for this reason, it behooves us to learn about the parts of the sarcomere and different regions of the sarcomere. So let's start off by identifying this thick red filament right here in the middle part. This is called myosin, and this is one of the proteins that is involved in making up the dominant content of the sarcomere. And this is one of the structures that's involved in creating the muscle contraction. All right, we have another protein that's involved, and that's this thin filament called actin. And in a muscle contraction, the actin is going to slide over the myosin, and that's going to create that shortening that we see in the sarcomere that leads to a muscle contraction. Now, a sarcomere is going to have at either end a Z line, and a Z line is where we're going to find the actin structures anchored. And the Z line also is the demarcation of the end of a sarcomere. So we're going to have a Z line off to the left and a Z line off to the right. And within those boundaries of the Z line is the sarcomere. Now, the actin can move, but the myosin doesn't. So what keeps the myosin anchored in place? Well, it's another protein called the M line. And the M line goes right through the middle of the sarcomere, and it is the anchoring structure that holds the myosin in the center of the sarcomere. Now here I've brought up two sarcomeres. I've got one here off to the left and one here off to the right. And like I said a moment ago, a sarcomere is defined as that region between Z lines, from Z line to Z line, keeping in mind that the yellow lines in my image here represent the Z line. So we've got two sarcomeres here. Now, the reason why I brought up two sarcomeres is because I want to talk about some regions that we're going to define on these sarcomeres, and they're important for understanding the function of the sarcomere when it's doing its relaxation and its contraction activities. And the first of the regions I want to talk about is it's bounded by the myosin, and this is called the A band. So I've got an A band to the right and an A band to the left. So we can define the A band as the length of the myosin that we have within a sarcomere. All right. Now, in the modules and maybe even in some textbooks, we could define the A band as the end of the myosin to the M line, and then continue that, saying it's from the M line to the other end of the myosin. We could do that, but as long as we understand that it is looking at the myosin, whether we're doing two halves of the myosin from the end of the myosin to the M line, and then the same thing on the other side, or whether we're looking at it from the tip of the myosin to the left to the tip of the myosin to the right, the A band is covering the length of the myosin. And if we look at what's being bounded by that, we can see certainly the myosin's in there, but we've also got the tip end of the actin. If we go to the tip end of the myosin in the sarcomere on the left, all the way over to the tip end of the myosin that's in the sarcomere on the right, we're going to have the I band. And if we look what's within the I band, all we have is actin. All right, so that's important to know. Now, there's one more zone we want you to know about, and that is the H zone. And the H zone is going to go from the tip of the actin off to the left in a sarcomere over to the tip of the actin on the right within that same sarcomere. So we could say that the H zone is only going to contain myosin. It doesn't contain any actin. All right, so why is it important for us to know about these different regions? Well, the reason why is because these regions are going to alter depending upon whether a sarcomere is in its contracted state or in its relaxed state. And so that we could look at a sarcomere visually, understanding what's happening with these different zones and bands, and make a visual determination. That's why. So here we are back with our single sarcomere, and it's currently in the relaxed state. But if we contract it, watch what happens. You'll notice that we had a big change right here, and we also had a change right here. So let's look at that again, but this time with our labels in place. All right, so now we have our labels in place. So here's our A band down here at the bottom, and it's bounding our myosin from this end all the way to this end. And we defined the I band a moment ago from the tip end of the myosin all the way to the tip end of the other myosin, but since we don't have that sarcomere here, I'm just going to stop the I band here at the Z line, and it'll still serve its purpose. So we know that it should continue on, but we're just going to stop it right here for now. So we know that in a relaxed sarcomere, we've got this distance making up the I band. And then up here at the top, we've got this distance making up the H zone. So let's see what happens when we ask this sarcomere to do another contraction. So let's have it contract. So what do you notice? Well, we can certainly see that there was a big change here in what should have been the H zone. In fact, there's hardly anything left at all. So we can see that with a contraction, the H zone reduces, if not completely disappears. If we come down to the I band, we can see that this is where the Z line previously was, and now that Z line has tucked in or been drawn towards midline, and as a result, we've seen that the I band has been reduced. But what happened to the A band? Well, because the A band is defined by the length of the myosin in the sarcomere, and that doesn't change, the A band is also unchanged. So let's recap what we just learned. We learned that we have the A band that is defined by the myosin. It contains myosin and actin. We know that we have the I band that contains only actin. We've got the H zone that only contains the myosin. And we know that during muscle contraction that the H zone reduces or might even disappear, that the I band will reduce in its length, but that the A band stays unchanged. And with that, we are done. Thanks for watching.